Welcome everyone. We're on our last lesson of the chapter. And a bonus, it should be a short video and it should be review because we talked about factoring by grouping when we were solving difficult trinomials that look like this. ax squared plus bx plus c. So, when can you use this? Well, in the example I talked about a couple days ago. And if you end up with four terms and you're able to group them so that when you factor something out, what's left will match in each parentheses. So let's do an example. First, I have to identify a common factor between these two terms. And I know that a common factor between these two terms will be w squared. Now, the other factor I have to identify is here. What's the common factor between these two terms? The common factor between these two terms would be a negative 7. So I can write that negative 7 here. The next step is to actually factor it out. So here's what I'm going to do. If I take a w squared out of this, what I end up with is a 2w. And if I take a w squared out of this, I end up with a plus 1. Next, I can move on to my other parentheses. If I take a negative 7 out of here, negative 14 divided by negative 7 gives me a negative 2w. And negative 7 goes into negative 7 one time. Just like before, it's very important. Look at this and this. Are they the same? Yes. All right. Then we can write our answer. Here's what we'll do. This factor and this factor make up my first parentheses. So my first parentheses will be w squared minus 7. And my second parentheses will be the parentheses that repeated itself, 2w plus 1. It is important, there's my 1, it is important to check your answer. So let's check quickly. 2w multiplied to 2w squared is 2w to the third. Negative 7 multiplied to 1 is negative 7. If I keep going, w squared multiplied to 1 is 1w squared, and negative 7 multiplied to 2w is negative 14w. It sure works. Here are two examples for us to practice with. So just like before, set up your two parentheses, put a parentheses here, and then put a parentheses here. And factor. What's the greatest common factor between these two? That would be 3x squared. Can go into both of them. And when you divide, you need to write what's left over. So what's left over here would be 2x, and what's left over here would be 1. Next, let's move on to this second parentheses. What's the greatest common factor between negative 2 and negative 4? If you have two negatives, you should factor out a negative. After I factor out my negative 2, I end up with this, 2x plus 1. Now, check them. They both match, which is very important. The last step is to write your two parentheses. You will have the factors which are outside. That makes your first parentheses, 3x squared minus 2. And your second parentheses will be the one that repeated, 2x plus 1. Could you do a quick check? Sure you could. Do it quick. 3x squared multiplied to 2x is 6x3. 3x squared multiplied to 1, hey, 3x squared. Negative 2 multiplied to 2x, negative 4x. And negative 2 multiplied to 1. Check. Okay, if you'd like, you can hit pause and try this one. Do that right now. Hit pause and try and do this one yourself. Okay, hopefully you identified that 2x can be factored out of this, and you end up with x minus 3y. And you identified that a 5 can be divides into both of these, and you end up with x minus 3y. That's important. They should be the same. And you take the red factors, the ones out in front, and that's one parentheses, and you take the blue factors that repeated inside, and that's your second binomial. Multiply these together, and they will equal this. Just like in our last video, in this video too, I'm going to remind you that before you start, you should ask yourself, can I divide each term by the same number or variable? In other words, could I factor something out? And if I look, they all have a t in them. So I could take a t out, and they all can be divided by 4. So I'm going to do that and rewrite this. I'm going to divide each one by 4t. Okay, double check. I divide that by 4 and t, and this divided by 4 is 6, and divided by t it disappears. Perfect. It does say rearrange your terms if necessary. Here's what I mean by that. If you look at these two terms and you can't pull anything out, try moving another term. Use the commutative property to move them around so that you can pull something out. But we can, so I'm going to go ahead and group. So I'm going to do that right now. And I know that I could pull a t squared out of both of these. They both can give up 2 t's and be okay. So I pulled that out, and here's what was left. 2t plus 3. Next I have to say, what can I pull out from a 4 and a 6? What can they both be divided by? I end up with 2t plus 3, because they both could be divided by 2. 2 goes into each of those. Okay, so don't forget my 4t. My 4t will be right here, and it's going to be multiplied to my red factors, t squared, the outside ones, t squared plus 2, and that's going to be multiplied to the one that repeated itself, 2t plus 3. Here is my final answer. If I multiply that all together, I will get this. Alright, it's our turn to practice this. So, what can I divide all of these terms by? What can I factor out? I know I can factor an m out, and I bet I can factor a 3 out. So I'm going to try that. Here's what I ended up with. If I divide these all by 3 and by m, because that's an m in each one, I end up with this. So next I am going to put parentheses around these two and factor by grouping. Okay, I identified that a 3 can divide both of these, and I can take 2 m's out from both of these, and here's what was left, 5m minus 1. Next I need to go after this parentheses, and I see that I can divide them both by 2. When I divide both of these by 2, I end up with 5m minus 1, and they match. Very good. Let's write it. Remember, 3m goes first. Next, I'll take my blue factors, 3m squared plus 2. Lastly, the one that repeated itself, the 5m minus 1. So those 3 items will multiply together to give us this. Alright, we have one more example and then the practice problems. I said that this would be a short one, so what can we factor out of all of these? We can factor 1x out. And what else could we factor? I bet we could factor a 3 for sure. So let's try that. Sure enough, you can divide all of these by 3 and you end up with 12x to the third minus 16x squared plus 3x and minus 4. And the x that we pulled out is right here. So now let's put parentheses around the first 2 and the last 2. Now, I'm about to do this, and look what I notice. 12x to the third and minus 16x to the third works great. But here's what doesn't work too great. This just has a factor of 1. So to be safe, I'm going to switch these two around. Here's what I'm going to use, the commutative property. So watch what happens. So I rearrange them so that I can pull out more than one, and watch. Let's continue now and put parentheses around the first 2 and parentheses around the second 2 to group them, and let's factor by grouping. Let's take a quick look here. I brought the 3x down, and I said to myself, what's the greatest common factor between 3x and 12x cubed? And I could divide each of these by a 3x. I could do that. So I divide this by 3x and this by 3x, and I end up with 4x squared plus 1. Now I have to say, what can I divide negative 4 by and negative 16 by? And I can divide both of those by a negative 4. When I divide by a negative 4, I end up with 4x squared and positive 1. So 4x squared plus 1. And double check, hey, these are the same. So lastly, let's write our answer. We have 3x multiplied to our blue factors, 3x minus 4, and then multiplied by the binomial that repeated, the 4x squared plus 1. There you have it. If you multiply all of this together, you will get this 4-term polynomial. Here are the practice problems. Please complete all of them and show your work, and then bring any questions you have to class next time we meet. Take care.